National Electrical Code does not specifically address whether you can splice a cable and embed the splice in mortar when repairing floor heaters. However, several sections of the National Electrical Code provide guidance. Section 300.15 generally prohibits splicing electrical conductors within a raceway, such as conduit or mortar. The exception to this rule is if the splice is made in a junction box, pull box, or other approved enclosure. The purpose of this rule is to ensure that splices are accessible for inspection and maintenance. Section 424.44 requires that floor heating cables be installed in a manner that allows for future maintenance and repair. This implies that the cables and any splices should be accessible without damaging the surrounding structure. Embedding a splice in mortar could make it difficult or impossible to access the splice for future maintenance or repair. The code requires accessibility for repairs. Embedding a splice in mortar typically makes it inaccessible. Since the National Electrical Code does not explicitly prohibit splicing and embedding in mortar, but it does require accessibility for maintenance and repair, it is important to consider the following factors. Firstly, local codes and regulations may have specific requirements or restrictions on splicing cables in mortar. Secondly, the type of cable being used and the manufacturer's recommendation should be considered. Thirdly, the method of splicing should be appropriate for the cable type and the environment. Fourthly, the splice should be properly insulated and protected from moisture and physical damage. It is always recommended to consult with a qualified electrician or building inspector to determine if a particular repair is code compliant in your specific jurisdiction. They can assess the specific situation and provide guidance on the best way to repair the floor heater while ensuring that the repair meets all applicable codes and regulations. The electrician or inspector can consider the specifics of the installation and the local regulations to determine the best course of action. Consider the specific type of floor heating cable being used. Some cables may have specific instructions or restrictions on splicing. Consult the manufacturer's documentation for guidance. Ensure that the splice is made using approved methods and materials. Use connectors and insulation that are specifically designed for the type of cable being spliced and the environment in which it will be used. Proper insulation and protection from moisture are essential to prevent electrical hazards and ensure the longevity of the repair. Before proceeding with any repair, disconnect the power to the floor heating system. This will prevent electrical shock and ensure a safe working environment. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the repair. If embedding the splice in mortar is the only option, consider using a waterproof junction box or enclosure to protect the splice from moisture and physical damage. The junction box should be accessible for future maintenance and repair. Alternatively, consider replacing the entire cable run from a readily accessible junction box to avoid splicing in the mortar altogether. Replacing the entire cable may be a more reliable and code-compliant solution in some cases. If the floor heating system is still under warranty, contact the manufacturer before performing any repairs. Unauthorized repairs may void the warranty. The manufacturer may have specific recommendations or requirements for repairing the system. It is important to follow these recommendations to maintain the warranty coverage. Remember that electrical codes are designed to protect people and property from electrical hazards. Always follow the code and consult with a qualified professional if you have any questions or concerns. Ignoring the code can lead to dangerous situations, including electrical shock, fire, and property damage. Take electrical safety seriously and always prioritize safety when working with electricity. Here's a breakdown of relevant NEC sections. Section 300.15 generally requires a box or fitting at each splice connection point. This is to contain and protect the splice. Exceptions may exist for specific wiring methods, but typically, a splice buried in mortar would violate this rule. Section 424.44 deals specifically with splices in embedded heating elements. It mandates that repairs and splices be made so the location is permanently identifiable and offers minimum exposure to damage. Embedding a splice directly in Mortar without any protection or identification would likely violate this section. Consider these points for code compliance. Firstly, accessibility is key. The National Electrical Code emphasizes the need for access to electrical components for maintenance and repair. A splice buried in Mortar is inherently inaccessible. Secondly, protection is necessary. Splices need protection from physical damage and environmental factors like moisture. Mortar alone doesn't provide adequate protection. Thirdly, identification is crucial. The location of splices should be readily identifiable for future work. A buried splice is difficult to locate. Alternative solutions to consider would be firstly, surface mount solution. If possible, transition to a surface-mounted heating cable system. This allows for easier access to splices and connections. Secondly, chase or conduit. Install a chase or conduit within the mortar bed to house the splice inside an accessible junction box. Thirdly, cable replacement. If the damage is extensive, consider replacing the entire heating cable to eliminate the need for a splice in the mortar. Before making any repairs, properly diagnose the problem. Use a multimeter to test the continuity of the heating cable and identify the exact location of the break. A thermal imaging camera can also help pinpoint the fault. Once you have located the break, carefully remove the mortar around the damaged area. Avoid damaging the heating cable further during this process. Clean the exposed cable ends thoroughly to remove any debris or contamination. When making the splice, use connectors and insulation that are specifically designed for heating cables. These connectors should be rated for the temperature and voltage of the heating system. Follow the manufacturer's instructions carefully when installing the connectors. Ensure that the splice is properly insulated to prevent electrical shorts and ground faults. Use heat shrink tubing or other approved insulation materials to cover the splice. After making the splice, test the continuity of the repaired cable to ensure that the connection is good. Use a multimeter to measure the resistance of the cable. The resistance should be within the specified range for the heating system. If the resistance is too high or too low, there may be a problem with the splice. Once you are satisfied with the splice, protect it from moisture and physical damage. Consider using a waterproof junction box or enclosure to house the splice. The junction box should be accessible for future maintenance and repair. Backfill the area around the splice with mortar. Be careful not to damage the heating cable during this process. Turn on the power to the floor heating system and test the repair. Monitor the temperature of the floor to ensure that it is heating evenly. If you notice any problems, such as uneven heating or tripping breakers, turn off the power immediately and consult with a qualified electrician. Also consider the following. Firstly, documentation. Keep a detailed record of the repair, including the location of the splice, the type of connectors and insulation used, and the date of the repair. This information will be helpful for future maintenance and repairs. Secondly, warranty. Check the warranty and the floor heating system to see if the repair is covered. Unauthorized repairs may void the warranty. Thirdly, local codes. Contact your local building department to see if there are any specific requirements for repairing floor heating systems. If the repair involves replacing a section of the heating cable, be sure to use the same type and size of cable. Using the wrong type of cable can cause the system to overheat or fail. Follow the manufacturer's instructions carefully when installing the new cable. Ensure that the cable is properly secured to the floor to prevent it from moving or shifting. Before backfilling the area around the repaired cable, consider installing a layer of insulation to protect the cable from physical damage. Use a material that is compatible with the heating system and the mortar. The insulation will also help to improve the energy efficiency of the system. When backfilling the area around the repaired cable, be careful not to damage the cable or the insulation. Use a trowel to carefully spread the mortar around the cable. Avoid using excessive force or pressure. Allow the mortar to dry completely before turning on the power to the floor heating system. Finally, safety first. Always prioritize safety when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the repair. Follow all safety precautions and wear appropriate personal protective equipment.